Take 2, electron configuration. Okay, so electrons move in different patterns called orbitals. There's 4 different types of orbitals. The first one is the s orbital. And the s orbitals are spherical in shape. S does not stand for spherical. It actually stands for sharp, but we're not going to worry about that right now. All right? Since it's spherical, there's only one type of s orbital. All right? Now, what does that actually mean? If you could imagine a 3-dimensional sphere, there's no way to turn it to have a different shape, right? It's always going to look exactly the same. So the electrons are always going to move around it kind of in the same way. On the left here, this is a representation where they use the equation, they figured out where the electron is over and over again, and throughout different time, you can see that most of the electron is kind of like in this area, and then occasionally it moves out. And again, remember, because this is the model for it, we're going to say that 95% of the time the electron is somewhere in this sphere. 5% of the time it could be anywhere, all right? But most of the time it's in here, all right? And you can have 2 electrons moving around each of these orbitals. Okay. All right, the next orbital is the p orbitals, and they're dumbbell shaped. As you can see here, they have this kind of like dumbbell shape to them. And if you also look, they're on all of the axes. So there's 3 axes. The dumbbells go on all 3 of them. And that's why there's 3 of these, as opposed to just one sphere. Does that make sense? All right. Since it's dumbbell shaped, there's 3 of them per energy level, since each can be on its own axis. Now, here's the interesting thing. What does this actually look like? Like, what would an atom look like that had all of these dumbbells together? Well, it would be a combination. So you would have, right here we have the X, here we have Y. So Y would get its dumbbell, and then Z would get its dumbbell. And you can kind of see that it's all 3 of these put together, right? All right, so we have that. And for each of these, you can have 2 electrons. So there's 3 shapes. Each of them can have 2. How many total electrons can the P's have? 6, right? And what was the first one we talked about? Yeah, 2, and it was the S, right? What was the shape for the S? Sphere. So it kind of fills in the other part, all right? So the S can have 2 as well. So in this energy level, how many electrons can we have in total? 8. We can have 8. What does that remind you of? Yeah, valence shells, right? Second energy level can have up to 8 because of this. Now it looks kind of like a sand dollar, right? But it's in 2 dimensions here. It's actually 3-dimensional. But either way, the first energy level only has how many electrons? 2, right? So it's just the S. The second energy level has 8. It's a combination of the S's and the P's, which gives you the 2 from the S and then the 6 from the P's. Does that make sense? Yeah. Okay, so that's how we come up with this. Okay, then things get a little bit crazy. The d orbitals are mostly clover shaped, as you can see here, but there's one that looks a little odd. There's 5 different shapes for them, all right? So for this, each energy level, you can have 5 different shapes. If you can have 2 electrons on each shape, how many total electrons can you have for this? 5 times 2, 10, all right? So S is 2, P was 6, D's are 10. Now this is total electrons, right? This is total electrons, all right? The number of orbitals, this was just one orbital because there was only one type of S. The P's had 3, and then the D's had 5, right? So you can see the number of orbitals, if you double it, that's the amount of electrons you can have in that orbital, all right? All right, everybody's good? All right, one more. Oh, before one more, This is kind of a better representation of what it looks like in 3 dimensions. Notice they're not really on the axes, right? Because the P's are on the axes. Now some of them are, which means they kind of have to share these other regions, but they're kind of, a lot of them are in between those areas, because again, all the electrons need to be near the nucleus, but they don't want to be near each other. So they come up with these odd shapes, like, you know, that almost looks like one of those inner tubes, right, for out in the ocean. Because they don't want to be in, you know, they can't be in the very center because that's the nucleus, but also the S's are in there too. So they're trying to find places to be around it. All right, and then these are the F's, which are, they're difficult to describe. They kind of look like mutated clovers, right? They kind of have the clover shape, but then there's double, or they're kind of oddly shaped. And there are 7 different shapes for this orbital per energy level. So for this one, because there's 7, how many electrons can they have total? 14. Yeah, they'll be able to have 14 electrons, which is a lot, because before in middle school, you're always told first energy level has 2, second energy level has 8, right? And then that's kind of all they say. They always just say, oh, there's always just 8. Well, we're gonna find out that there's actually a lot more. You can get a lot more throughout this chapter. All right. Okay. So what we're going to do here is on the back of the packet, there's a periodic table. We need to outline it real quick.